Okie dokie. Oh, I'm trying out this thing where I eat a little earlier in the morning. Well, I try and basically eat my shit early as possible. I'm kind of fucked today though, because I don't have dinner. I ate shit in the morning. I had dinner, or I had lunch at work, big lunch. Had some fucking snackage after, and then that's it. Now I have a little bit of lemonade. I don't have anything I want. I don't want to eat anything I have right now. I don't want to fucking defrost chicken and then cook it. It's just too late. I'm trying to eat earlier, but it's having a negative effect on my energy in the end of the day, which is it's probably fine because I go to bed in 2 hours, so my energy should be ramping down. But it's annoying because I haven't eaten in a while, really. So like, I'm just fucking losing control of my body, yo. Excuse me. Okay, made big progress on Project Extrasensory. So we are adding extra senses and making the senses extraordinary. You could almost say extraordinary sensory, but that's just too long. And it's worse. Extrasensory is cooler. It's that psychic move in Pokemon. That's the project that I'm calling the objective of this channel and my company for now. Haze Infinite. Excuse me. So, the objective is to improve sensory capabilities of VR, or more improve the implementation of sensory capabilities in VR, improve the unexploited sensory capabilities in VR. Because right now, scent, not so much, taste, not so much, but taste isn't super important. Like right now, taste or scent is the main one, and then later will be touch. We can see and we can hear. Cool. Basically, 2 out of 5 done. Taste, we can put that on the back burner because it's not super relevant. It's relevant for specific games, but not the games that I want in enough of an area that's important. Right now, scent is more important. I'd rather smell the cave, smell the enemy, smell the bar, smell the food, smell the plains biome, smell the forest, smell the icy nothingness, smell the desert, and see and hear it, then taste it for now. So, smell is the main one. And then collabing with people on touch to make things feel better. Like, I'm holding a sword in one hand, and it's got this long hilt, and then the guard, and I can feel each of the pieces and manipulate my fingers independently and feel the thing between them. So it feels like I'm holding glasses. Don't feel anything, don't feel anything, don't feel anything. Oh, my index finger feels something. Oh, my middle, ring, and then etc. I feel all that shit. So making the feelings closer to what's actually happening. And that might spearhead improving the accuracy of the tracking. Maybe the tracking's already there and it's just the sensation part. But maybe not. So, I could be working on, right now I'm figuring out how to incorporate, or how to, let me see. I guess, do I have a Yapathon full screen? Nah, it's not important on this computer. So, I need to have Unreal Engine. I saw a hair. It moved. I thought something was coming from over me. I have Unreal Engine, and it needs to talk to this Arduino. And when I do something, make the Arduino do something. Which means I need to make the Arduino do something, and then just affect that behavior. So I need to start the behavior of the Arduino when the computer starts. Whatever. Turn it on. Cool. The Arduino's doing its thing. But it doesn't have a variable is false. In Unreal, when I put the variable to be true, I want the Arduino to start to, it's looping to do something. So basically the Arduino starts and it's looping, but every single time it's seeing that this variable is false, and the variable would be can emit sent or should emit sent. Not is emitting sent or anything, but just should or can, something like that. So can, we'll say should, because maybe it is, but it shouldn't. So should emit sent. Okay, it's false because it's on, but we haven't received anything from Unreal saying go, go, go. Start the loop. Start the loop of 10 seconds of smell, 5 seconds pause, 10 seconds smell, repeat. So we're going to do, Unreal needs to send a signal to the Arduino. And apparently the best way of doing that is through serial COM ports, which are, I guess, USB communication, sending some sort of signal to some area which the Arduino can read from. And I can send messages in characters, in strings. And the Arduino can read that. And then its loop will say, hey, if this shit is true, or if the message is this, set this variable to be something. I can't say from Unreal, yo, Arduino, set this variable. I have to instead have it so that the Arduino will set that variable depending on what it sees. So I have to basically put a signal in front of it. So like I can't say, hey, bull, be aggressive now, but I can put a red thing in front of the bull or a colored thing in front of the bull, and then that will trigger it. So right now I need to figure out what things do I need to put in front of the bull, the Arduino? How do I communicate that? What is it exactly that it needs? And how do I design the bull so that it gets angry properly? It doesn't get angry out of nowhere for no reason. It gets angry only when it should. So that the Arduino plays sent and emits sent only when it should, and exactly when it should, and not otherwise. That's what I need to do. So there's an algorithm in there I need to figure out, and then, which shouldn't be too hard, I just need to figure out specifically how the Arduino looks at the COM port and what's going on there. So I have a trial application I downloaded and installed, and I'll use tomorrow. I'll experiment with it. Or maybe tonight for a little bit. I think I'm going to split my efforts. So working on company sensory endeavors, meanwhile expanding my programming capabilities. So maybe we do half and half, do an hour and an hour or something like that tonight. Let's see, what is this function? What's happening here? Oh, it just didn't save that these were supposed to be deleted. Let me just make sure this works. Cool? Okay. So we'll do that in a little bit. So I'm going to need to get the COM port stuff. I think I'm going to do it on my laptop so that I can do it anywhere. And then we'll see. So I'll do, oh yeah, and then maybe I can, well, there's the COM monitor. Yeah, I might just experiment with it on the laptop and then later on see if it works here. I remember, because I have Unreal on my laptop actually. I was doing Blender and Unreal before, but I forgot that Blender was on. And when both were on at the same time, Unreal wasn't able to open up animations. It would crash, the whole Unreal would, because there was stuff going on Blender and stuff going on Unreal. I just forgot that Blender was on the entire time, and it would never work. And I had to like open up Unreal and really quickly try and do something in an animation. Super fast, before it would crash. Never worked. Eventually I just fucking closed Blender and it was good to go. It uses like 70-80% of the capabilities, and then Blender topped it off at like 1920, and that capped it. But now we should be good. So I'm going to use Unreal, connect it to the Arduino, without anything else, just the Arduino, and then I'm going to have the COM port, and I'm going to do stuff in Unreal to write to the COM port and practice doing that first while watching the COM port. Basically, it's like a chat box, watching a chat box, and I'm trying to do things to put stuff in the chat box. It's like, it's probably hard to do it. So I'm going to do a bunch of stuff and then finally, oh shit, okay, I can do it. Cool. All right. And now, excuse me, write something in the Arduino to do stuff with that and then see how it works. Is it, the Arduino has a loop, and the second it sees this, it sets something to true and it goes forever? Is this message still here? Can I like look at it later? Does it keep on looking here and sees it? Or does it look here and not see it anymore? Is there a way I can like save this as the message and then keep checking, and once the message is different from the last message, so it's like, hey, let's say the message is start. Okay, so it stores start as a string or a character, whatever. It seems like in the Arduino, it has string as a variable, so it's a sequence of characters. We could say I could store it, and then as long as this message that we've stored matches the current message, just keep on doing the thing. And then the second it doesn't match, then whatever, something else, maybe. Or maybe I have the message already hard-coded in the Arduino, and when it messages, there's different ways of doing it. I just need to understand how the COM port communication actually works. But for now, we're going to continue with the procedural random number generator stuff. We were rolling dice. We were doing steady clock. Ooh, seed REQ. All right, there's so much stuff going on in here. All right. Okie doke. Excuse me. We see everything. All right, let me move this over. Cool. All right, we're good. So you need it. So every single time you open the program, something about the seed is different, or the seed is different. Well, how do you get a different seed? You need to get a different value at runtime. So you need to be looking at the same thing, and that thing needs to change its value. Its result needs to change every time you evaluate it. And what is constantly ticking? Time. So we use steady clock. That's one way. We haven't done the random device though. Okay, we use chrono. We do steady clock. Cool. Yeah, if it's done super quickly, then it won't necessarily be different. So if we're wanting literal randomness and we do it one time and then we do it next time, they should not be associated with each other. They should be, if I do it boom boom, those two results should be just as close to each other statistically as boom, wait forever, and then boom, because those are both random. The time between them shouldn't matter. But here, boom boom, the time hasn't changed as much as boom boom. So the latter, boom boom, those 2 points are probably more different than boom boom, those two different in terms of time. So if the algorithm is just manipulating something, it would be manipulating a more different variable the longer we wait. So right now, it might not be good enough for some purposes if we aren't sensitive enough, meaning that the value doesn't have enough significant figures to be different enough from something else. If we're changing it and we're getting some vastly big number or some vastly different number by doing the same change, well, one way of increasing the difference between one number or one seed getting changed and then one state getting changed in another state is by increasing the difference between those states in terms of the bits. So if we instead do more bits, just give it more significant digits, then more change. So, fingerprint shit. Okay, if it's around quick succession, yeah. Okay, so we could do high resolution to get the smallest distance between any two, like we're measuring time. It seems like to more significant figures, or at least more accurately, something like this. The most granular unit of time. So instead of milliseconds, it's whatever's, which is effectively more significant digits. But it's more precise. So it has more precision. We're setting precision before. We've done that, where we've changed the amount of digits, just like bool alpha, changing how the stuff gets output. So we output a number to a different precision. So if we measure it tinier, the differences will be bigger. So instead of it being whatever, let's say we measure to the 100th place and we do 0.01 and then we wait just like half a 100th place, so a 200th of a second, and we do it, or slightly less than a 200th. So we're at 0.0149, not rounded up to 0.02 yet. We'll see 0.01, 0.01 for the time. But if we increase the sensitivity, the precision, we would see 0.0100, 0.0149. So in the first case, if we had done it, there wouldn't be any differences between the numbers. But in the second case, there would be differences, which means you're probably more likely to get more differences between numbers if you increase the precision. So we could do this. but it could use the system clock, meaning that the user could manipulate the system clock in order to get the same seed. So he waits at some point and then just sets the clock to go back to the seed instead of having to wait fucking 24 hours basically. Can't be adjusted. Steady clock, hence steady. Random device is implementation defined. Okay. It depends on type of Windows or LinkedIn, or not LinkedIn, fuck me. Linux, those things, the specific, maybe the processor, the architecture of the device seems like, or maybe it's only the operating system. If no guarantees to calling yeah, so we do it on this architecture, it's not guaranteed that it's going to work on this one, or not guaranteed that it'll work as well. So maybe we do it on one. Maybe on PC, frames in Marvel Rivals are not correlated with attack speed, but we do it on PS4, where we did the same shit on both, but because the thing we did was implementation defined, we didn't control all the way down to make sure it was the same on both. Well, we get different results. On this one, the attack speed actually scales with the frames. So on console, if you get 59 frames, your guy actually moves slower than a guy who's 60 frames, who moves slower than a guy who gets more than 60 frames. So, random device will ask the operating system, hence implementation defined, it's asking the operating system for a pseudo random number. And how it does this depends. Okay, so the OS, I guess, not C++, the OS, the operating system, has some sort of random number shit inside it. And random device taps into the random device of your operating system. So we could just seed the Mersenne Twister as the random device. What the fuck is that? Random device. It's like an object, but then we're calling something too? I don't know what the fuck that is. Okay. So, like, random, what is it? Standard random, or hold on. We'll just do this. Include input output. Need to output random values. Include, and these aren't random. These are PRNG values. Include random. Need Mersenne Twister. Yeah, and then we need the random number generator to seed the Mersenne Twister and random device. Cool. Okay. So we're gonna do standard MTD this guy. We're gonna call it get random num, and he's gonna be seeded with standard random device, which for some reason is initialized to be something, but then that, I don't really know why. So we're doing random device, but it says right here, random device parentheses. So it's like an object, but then we're also calling something? I'm not sure how that works. I don't know. Does that look cool? There's an error. It doesn't like that. I'm curious why. Oh, well, we didn't finish the initialization. Okay, alright, so that's fine. Alright, interesting. And then we can just do standard uniform int distribution, and it'll be called D20. And this guy is not seeded to be anything. Or, oh, sorry. The range is from 1 to 20 because it's a D20. 20-sided die. Seed Mersenne Twister with OS's random device. Cool. And then we'll just say for int start num, or int current roll, which will just say 0, and then total rolls, and we'll say we're going to do there's 19, and then we'll just say while current roll is less than total rolls, and then increment current roll. And we will do a few things. We're going to, oh, actually, we maybe don't need that. Let's keep it not nested. We're going to use standard character output to output D20 and D20 of get random num. So we're going to get a random number. And this is probably bitching because of the semicolon. Yep. So we're passing in the function of getting random number. Well, it's not, I guess it's a function. We're passing in the identifier of the Mersenne twister. That way the Mersenne twister's function, its member function, operator parentheses, can be called by the uniform standard distribution D20. Because I don't know if it's taking a pointer to a function. I guess it's taking a pointer to a function. That's what it seems like it's doing, D20. The int distribution takes a function of a Mersenne twister. That way it can call it and then limit the value and then output the value. So we're outputting that random value limited between 1 and 20. And then we are doing, yeah, so if we could do this, then we could do \t and then, oh, but then within this, so we actually need multiple lines here. If current roll is divisible by 5, so if its remainder with 5 is 0, we will output in line. Cool. Let's see what we get. So we get, oops, what the fuck is happening here? Remainder 5, 0 with a remainder 5. Okay, so we actually do need to start with 1. That makes sense. Yeah, because we do that and then it instantly goes to the next line. Okay, cool. All right, so it makes sense. But in this case, we're doing that so we are going to get a one-off error, so we need to increase it. All right, cool. 8, 2, 1, 8, 19, 6, 12, 13, 12. Yeah, doesn't seem bad. Seems okay. A lot of even numbers? Maybe not. Odd, 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 odd. That's a lot of odd. Seems cool. Do it again. 7, 7, 9, 7. Any patterns? 12. Seems cool to me. So we can do it a couple different ways. We can use the standard operating or the operating system's random device that's built in. And for some reason, I guess we're initializing it, but then we're doing something else. I'm not sure what these operators are doing for it. I think you'd have to know specifically. And it might say that here. Of course not. There it is. Cool. Nice. Okay. Excuse me. Seeding it with a random number from a temporary instance of that. Meaning random device exists, and we're creating a little one, and then we're using that one. Seems like. Seems like here we're initializing a random device, but then we're also calling after. Interesting. That's what I would guess initially. So these are objects, it looks like. Hence it said instance later. We've never dealt with objects before where we pass things by identifiers, except, well, I guess that's not necessarily an object. MT is, but, so maybe we're just passing it the object, actually. So a uniform int distribution takes an object that has a member function that yields a number? Something like that? Yeah, because it's implementation defined, so some other ones don't necessarily need to be non-deterministic. Yeah. Some random things are cool. Well, So would the clock be non-deterministic though? The algorithm's deterministic, obviously, but it's a deterministic algorithm, but it's seeded with something that's not really random, but here, so maybe it's more guessable. I mean, you could just time it 24 hours for the clock, and if you get some shit that's pretty similar at the exact time, then maybe you've guessed that. But here, maybe it's even easier to guess the random device. It could produce the same sequence every time it's run. Meaning the same sequence every time. If it's the same sequence every time. Oh, if it's non-deterministic, then it means that it can't be the same number every time. So, but sometimes it is the same number every time. Meaning that random device can just yield the same fucking value? Yo? Okay. Oh, good. Cool. Use it to seed. Use that to seed. Wait, best practice is use random device to seed them? Really? Yeah, I guess steady clock's kind of a pain. What does it mean? Yeah, so it creates a value initialized temporary object and then calls some shit from it. And it has operator parentheses, which returns a randomized value. It's the equivalent of calling a function. Calling the following function from it. So it's like there's hold on. So that's the same shit, which is interesting. So there's a function within random device. Calls that operator. So a member function, I guess. We're talking about calling something on an object, and it seems like it's a function. Same result. Let's see. Oh yeah. Instead of having to oh yeah, we're not even naming it. Yeah, we just make it an unnamed object. Yes, I could create a sword and then unname it. How would I even get it in memory though? I wouldn't. In this case, you just use the value and then oh, hence that's why it's temporary. We haven't named it. Okay. Uh yeah, we don't know how expensive it is. We don't know how high it can go. We don't know the range or the kind of efficiency. Yep, could be depleted quickly. Yep. So basically, we seed PRNGs. We use a small, maybe questionable reliability, but okay in small cases, random number to seed. Or yeah, so we use a limited scope random number generator to generate a number, to generate our seed for our larger scope but deterministic PRNG. Okay. Let's do this again. So we'll say, yeah. Okay, so we can get a Mersenne twister and just call it get random. Or actually, what's a use case here? Let's think. Use the brain. Another random thing. Attack angle. We could do like I'm not a big fan of cats. Let's do cat behavior. Hey. So we'll have a function with a static Mersenne twister that is seeded, get the random number, and then convert it to cat behavior, and then get cat behavior. So we'll say get cat behavior. Cool. Okay. And we'll just do the functions, and then I think that's it. All right, so we'll just call it cat behavior. Oops. If not defined, cat behavior. Define cat behavior. And if. Oh, that was cool. I got to go up without. Really? Is that. Oh shit. Do I not have to do that anymore? Fuck. Maybe I just fat fingered. I don't know. Okay. Namespace cat behavior, we'll say. And then we'll say there's two functions. There's one function that is just, or we could say, we could have another header file too, but whatever. We'll just do, we'll return, yeah. Return a const int. Yeah. Constant. Stuff's known to compile time. Maybe you could do const expression. Oh yeah, because there were const expression functions. Okay. What if we just did that? Const expression, that way it's evaluated at runtime. I haven't, or at compile time. I haven't done that in a while. I don't even remember it. Const expression int get random number, no parameters, and then let's see what happens here. Cool. And then we'll do returning, so it's that. I don't know if that can be known at compile time though, because maybe that gets called at runtime. We'll find out. So maybe we can only do const, but it's okay. Then we could return, oh, and this will just be void. Void get cat behavior. Cool. Then we'll have this, column cat behavior is the implementation file. Copy the namespace over. This needs include iStream. You can just copy both of these actually. Cool. Oops. Alrighty. Don't know what I did there. Alright, so for getting a random number, we need to get a standard. Okay, we've included this, which includes this. Yo, fucking wake up, bro. There we go. Cool. Mersenne twister, and we'll just call it random, or generate random number. And he'll be seeded with the temporary random device, which will be value initialized, so it's temporary, and its function, which yields a random number. So we will get a random number, or so that seeds this guy. This needs cat behavior. What's the issue here? I'm curious. Oops. the fuck happened? Okay. There we go. Alright, and we're gonna return. Yeah, I think it's because this isn't known at runtime. Return. Oh, we need. Yeah. So we also need the uniform int distribution. So we'll have call it convert num to range, or convert random to range. Random num to range. Okay, and it's numbers. So just 1 and 10. And then return, convert, generate. No. No. What is happening here? What is wrong with? What is going on with? Oh, so if we just made this const. Then it's okay. Yeah. So the point is it's saying, hey, this function contains shit that cannot be evaluated at compile time because random device must be evaluated at runtime. Seems like can't just get the number now. Line 14. Okay. All right. So get cat behavior will say int. I will say. Well, this can't be a const expression because it's not known at compile time. Say constant. Cat behavior, and it is initialized to be get random number, and then we'll say we could do switch cases. Yeah, we may as well do that, right? I was gonna say from like if it's 1 to 10, and then we'll just cut it into slices, but we could just say 1 to 4, and then do switch on cat behavior, and then do case. Oh wait, case 1, and then oh wait, and this is something and break, and then case. Oh wait, and this doesn't need to be in parentheses. Case 2, something break. Case 3, something break, and case 4, something break. Cool. This is actually okay. It's not doing anything yet, and there's no default, so it's fine. So we'll do 1, and then we'll just say cat scratches you for no fucking or for no reason. Cat decides to be cool. And we could have it to be we assign it and then just print it at the end. So we could have like a standard string, and then we just assign values to it, or we could just print a constant. I don't know really what difference it would be though. Cat jumps away and flees. Cool. And then cat makes weird noise. What is missing here? On 26. Oops. Cool. Okay. Bro, 3 weird noises in a row? Okay. So random device. Pretty dang convenient. Okay, we're creating this temporary variable, and then from that, after initializing it, calling this function that it has. And we don't use that number by itself, the random number, because there are limits to that. It's a lower scope guy, meaning it's just not the more limited. Sure, it's better randomness, but it's limited. We don't know if it's expensive. We don't know if it gets wonky if we get outside of its purpose or its allowed range, something like that. Okay. Only seed a PRNG once, because we could do it once and then later on we could reseed it again. Just let the PRNG do its thing, and the question is why. Can be reseeded. Oh, so would we make it we would make it const because then we can't change the state. Essentially reinitializes it. Generate results starting from the new seed. Should be avoided, as the results can be less random or not random at all. Yeah, so instead of it being boom, 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 it could be boom, and then you set it to be something else, and then maybe that's more likely to overlap with other stuff. Like if you do one number and it's doing things, it's unlikely to hit those numbers. But you might do another one, and then in that case, it is like in this one, like we do one, and it just so happens that it doesn't really like odd numbers. And then we do another one, and that one happens to like odd numbers. Well, I don't know. Maybe that's good, maybe that's bad. Common mistake. I'll say I don't see anything bad just yet. Okay. So we have this random hold it. Oh, okay. So we are creating Emerson Twister. We are seeding him to be the random device, and then we're using the random int distribution to limit that random value to 1 and 52, and then we return that value. So every time we call it, it seeds the Emerson Twister to be the random device. So you should probably get a random number each time. Maybe if you the reason is because when we're reseeding a Mersenne Twister, we already know that, or we can assume that the random numbers that we can seed the Mersenne Twister with is fewer in number than the amount of numbers the Mersenne Twister can yield. Which means if we keep on doing the random seed, well, the Mersenne Twister is yielding values from, well, there's double randomness here, so not as much because this is also random. It's taking the number and randomizing. Well, actually, I don't know if it is. If you pass it the same number, it might just be passing the same stuff in there. I don't know. I think that's how it is. So let's say it is. So if we do the random device, and the random device, let's say, is really random. It's more random than the PRNG, and we don't have to seed it or anything. It's just there. It's just random. But it's only from 1 to 1,000. If we seed our Mersenne Twister and then we keep calling it, our periodicity is greater than 1,000. So it'll take more than 1,000 runs to get the same number. It turns out that our actual random device is less random than the Mersenne Twister. So if we keep on seeding it, eventually, after 1,000 times, we would expect to have gotten a second, duplicate random number, which means the Mersenne Twister would have done the same number earlier than it should have and been less random than it should have been. And then assuming that the uniform int distribution just converts some number to this range and doesn't randomly do that. It's not like, oh, big number, we're gonna pick somewhere between 1 and 52. Because otherwise, we may as well just say, yo, just pick somewhere between 1 and 52. It seems like it's gonna pass, and we pass it the same number each time, and then it does random each time. Uniform int distribution would be our random one. The uniform int distribution should be outputting the same number if we give it the same input. So like if we do, yeah, I mean that's what it's doing. If we say but we can't just pass it a number. We have to pass it a fucking Merson Twister. Ay, ay, ay. Oh, that's the issue right here. Wait, maybe not. Hold it. There it is. Yep, doesn't match the argument list. Okay, well, we can't do that. So, all right. Well, if we do the seed and then we pass it. Oh wait, hold on. Let's see. Yeah, that'll work actually. So instead of this, we'll just do this twice. So we'll say standard Merson Twister, and we'll just call it get random num, and then we'll just seed it to be 0. We'll just value initialize it. Cool. Okay. And then we're just going to output convert to range, and then get random num, and then boom. Okay, easy peasy. Boom, 82. Boom, 82. Yep, so the same random number that it got. So if we instead just did get random num, and it probably is okay here because this is an object, so we don't have to use it, I guess. 34999, 34991, 3499211, whatever. 3499211. 34992116112. 34992116112. Let's go. All right, cool. Guys back in the day used to remember girls' numbers like that. Holy, I need lemonade. Be right back. Oh, I'm getting tired but wired. Weird. Okay. Okay, so if we seed him with 1 out of 1,000 options that are really random, but only 1 out of 1,000 options, we actually make our guy less random. Boom! So don't do this. Why? Every time we're seeding this motherfucker with this. instead of making this shit
static. Make it static.
that way. He's initialized the first time you call get card. Well, actually, he's initialized. Well, hold on. Yeah, he's given a value of 0 at first. He's value initialized at compile time. And then, oh, we call get card, and then he's initialized once. And then, uniform int distribution is initialized here. And then, boom. And then, do it again later. Technically, you can make this guy static too. I guess it doesn't really matter. No, we'll just, whatever, just create him. It's fine. Create him, and then boom. And then create him, and then boom. Create him, and boom. This isn't getting run anymore. In the get card function, the random number is being created and seeded every time. Yes, so we would want him to be static. Internal state is that many bits. Underseeding, okay? I'll be back. I hate having tonsil stone issues. Back right side of my throat is sore, just because who knows why. Just a little bit. And I could never tell if it's a tonsil stone or not. I didn't think it was, but I thought maybe, unlikely. It's not. Okay. Internal state requires a whole bunch of shit. Yeah, which means probably, well, I don't know what a random number is, so, but that's a lot of fucking bits. That's a lot. It's the internal state. I don't know what that really means for the seed, though. It seems like the seed would be the state. You're setting the state, the initial state, to be the seed. I don't know that all those numbers would need to be necessarily set, though. I'm picturing a big number with a bunch of leading zeros, and then you do the algorithm to change it. I guess the point is you get a smaller number, so smaller number means fewer digits. Less random, so if you keep seeding small, you're limited to smaller stuff. Okay, makes sense. So the 64 done does. Oh, wait, what? Hold on. Oh, okay. Wait, hold on. Oh, so you can either do 32-bit values or 64-bit values, but the internal state is the same. You went fast. Gotcha. Yep. Whichever's the fastest to assign shit to. If it resolves to that, yep. Meaning that sure, maybe it's faster, but then maybe you're more likely to underseed. Yeah. Well, yeah, it could just be. Yeah, maybe there's a default random value, or it has tiny other sub PRNGs. Like there's one big PRNG, and then it says, okay, hey, take this or on once this thing is made constructed, set the value to be whatever. Like do this with the seed. Okay, what if the seed is too small? Set these other values to be 0, or do they have like sub PRNGs where each one of them is semi-randomly given another number? Then what are those seeded from? I don't know. Underseeded or suboptimal for the highest quality. Oh. Never generate 42. Seed sequence. Mm-hmm. Yeah, we can't get. We would need a whole new random number generator to get it. And we may as well fucking use that at that point. Oh, and then seed with that. Gotcha. Unbiased seed values. Seems like it's pretty fucking good then. So is it another? It's a thing that is initialized as something. So it's some type of variable, some type of identifier. But random device seems like it's an object. In this case, we can pass it different amounts of shit. Single value. Oh. Oh, because it'll go and then mix in the rest. So if we say that the remaining 623 integers are all set to 0 by default because they haven't been seeded, they haven't been assigned a value, then this guy will generate something that just like some generic-ish number that at least mixes the stuff up. I'm not getting a complete grasp of this won't add randomness, but it will get us a better mix of 0 and 1 bits. It's not any less likely for something, but it is different. So that maybe the first thing isn't as bad. First number isn't never 42. The more random we can provide, the better. So we could use random to do a bunch of ones, and then we call it and give it a bunch. And then we seed it using SS. Yeah, so we could do fix underseeding. Okay. So we'll have excuse me. I'm just gonna do 1 and 19, or 1 and through 20. Cool. And then we'll just have cool. We'll have get random num. Oops. We'll return int get random num. This needs to be for declaration. Nope. Cool. And we'll say we have a static merging twister. This needs the random part, so we'll do cool. All right. But this will be seeded later. So we're gonna say we'll create a non-temporary random device object. That way we can call it just shorthand multiple times. So we'll just say standard random device. Or we'll just say number maker. Initialized to be whatever the fuck. Did we initialize this or anything or no? No, we valued and then just called them. And then we'll make a standard seed sequence and then initialize them to just be number maker, number maker, number maker. It's cool. All right. Pass 3 random values. He fills in the rest as the seed sequence. And then we can see this guy using, this guy doesn't have a name yet, seeder. Boom. Never mind. Hold on. Oops. Fuck. Hold it. Yo. What? Oh, okay. Random num. So this should be instead. What is this shit called? Oh, we don't even have them included yet. That's why. Oh, functions. Bro. Bro, it's literally oh, because the for declaration. Forgot. Whoops. Okay. So, saying this guy yields random numbers, limited range limited to what plus can do. You pass this guy 3 random values, and he seed sequence fills in the rest wherever he's used to seed. Seed Mercy and Twister with Seeder. Seed sequence. Cool. And then we'll return the cast. Boom. Oh. Some negatives. What we've got. How about we have a converter guy? So we'll have standard uniform int distribution. Just call him B. Num range or convert num to range or convert empty num to range. 100. Turn convert. What are we passing him? Are we passing him something? Am I brain dead? Oh yes. Yes indeed. Generate num. Boom. Boom. Oh, look at that. Oh, I'm getting tired. Holy shit. My eyeballs. Oh, the dogs woke me up an hour early. Oh my god. I forgot I woke up to howling at like 6 o'clock. Oh god. Oh. I finish this? I need to finish this so I have time to drink water and get the sugar out and then brush my teeth. Ugh. Looks good. Okay, so we have cedars to hopefully reduce the issues of underseeding. All kinds of shit. Warming him up. Yeah, let's see what we have here. Yep, so we're passing the cedar some random numbers. Yep, then we're using the cedar. Creating a number generator. Reusable. Print a bunch of them. Doker. Damn, son. God. He's reusable because we're using them here. Seems like maybe it makes sense to make him static in my previous case, so that the object already exists. Because in here, it exists in this function. We're just calling and he still exists. But before, we'd call create him, call create him. Bunch of numbers. Okay. Really, there isn't much reason not to do this. Yeah, just because your numbers get better. Why not give it 624? Well, but it takes time, son. And depleting pool of random numbers, meaning it literally runs out, meaning it's got a limited amount. Or, well, yeah, I guess seems like that's the actual answer. Also do other random inputs. Yeah, from the clock. You could do different ones, so we could create a crazy ass seed for the Mersenne Twister by passing it in clock values and random device values. Okie doke. Current thread ID, the address. Just a bunch of shit. Okay. This article. Nope. Well, yeah, I mean, you could do like, oh, want a random number. Okay. Do the number of fucking polygons in the enemy that character last looked at. Like, probably pretty random. Or the locate, not the location, but like the some sort of thing, like the number of something in a something. Plug that into a PRNG. Oh, meaning, so we could just do a smaller number of calls. Yeah, 128 bits of state instead of fucking, what is it? 19,000 whatever. When it's underseeded, the initial results might be shitty because the initial results have a bunch of fucking zeros. Which means maybe if you're multiplying or whatever to it, you get smaller numbers, which means you get a bunch of zeros. Then maybe those aren't very different from other numbers. Oh, so like in the very beginning, if you start small, you get a bunch of small-ish numbers like, oh, 40,000, 50,000, 80,000, 100,000, 4 billion, 6 trillion, 480, whatever. You get numbers that are super random looking later, but in the beginning you get numbers that aren't because they're just smaller. Warmed up. Where you do, oh, okay, that makes sense. Where you just do it so. Oh. So it's static, and you basically just run the fucking PRNG a bunch of times to update its state to be a good state. Makes sense. Yep. Few hundred to few thousand. Rand has a bug for the first result. Interesting. Older ones are using Rand to discard the single result. That performs a warm up, so we don't need to do it necessarily. Well, yeah, because it goes through and it fits all the ones in, so you don't get all those zeros in the very beginning where you get a tiny little number. Random numbers across multiple functions or files. Okie doke, that's next time. True. Oh, yeah, so temporarily seed it with a specific one. That way the shit is the same time because it's PRNG. If it gets seeded at the same time, values at the same time. Yeah, so. Oh, and if you find the erroneous value and you see what that one is, well, fucking print, seed it with whatever that shitty behavior is. Yep, keep changing the seed value until you find one that does, and then keep using that one. Yep, makes sense. Wow, make your program be consistent so you can debug it. Okay, generating the same sequence of numbers. Bro, the seed ain't changing, yo. You didn't seed it properly, buddy. Same number over and over. Like you're not calling that motherfucker. Yeah, so you're either doing one number and you're just reseeding it every single time, meaning that your Mersenne Twister is not static, meaning that it gets seeded when you call it, every time you call it instead of just one, or it's either you're seeding him every time, or you're creating the new random generator. Wait, hold on. Or you're creating the new NT. So if he's not static, then he exists each time, or you're reseeding him. So maybe he's static, but for some reason we're still reseeding. In my case, you're creating him and seeding him each time. So you're reseeding. Well, you're not. I guess you're not reseeding him because you're killing it every time. So don't reseed him. Because if you do, the numbers which you're using to seed him are limited. So use the number one time, and then let it generate the subsequent states with its own algorithm. KO. Bop. 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 Oh shit, just quick. Alright. Alright, let me save this brain power for tomorrow. Because tomorrow I'll eat more. Then in a second, I'm going to go to my laptop, I think. And then on the laptopper, we'll do. Oh, well, Mike was in a really bad spot. Whatever. We'll do maybe some Unreal stuff. Test her out. At least get the plugins installed and. Something like that. Yeah, just to test. And then I'll just have default input or something like that. And then just have spacebar to do this. And then something else to do that. I think that probably makes sense. Yeah. All right, I'll do that. Maybe.